Hi, and welcome to Intro to Business Data and Analytics, BUS 665, Storytelling with Data. So one of the things we want to do is make sure that we're aware of the key and important aspects of business and data analytics. And so we will discuss it very briefly on the key concepts around that. So one of the perfect examples of why data matters is seen in the movie Moneyball with Peter Brand's first day. So you will have a short clip of that video, which will be posed a question about the significance of why data matters. But I think Moneyball paints a picture clearly of why data matters. So what is business analytics? Analytics is extensive use of data, statistical and qualitative analysis. You explore and then you also use it for prediction. So you create these models, these mathematical algorithms that provide the ability to see in the future. And of course, that's figuratively, gives you the ability to kind of project out what possible sales might be, what the outcome of a pandemic might be, and other key important matters. So think about it that way. Is that we will use business data analytics in every aspect of business in order to make key decisions on how we want to run our business, the day-to-day operations, as well as projecting to the future on what we want that business to look like 5 years from now, as an example. So key statistics about business analytics: investment and adoption, market size and growth, impact on business performance, job market and salaries, challenges and issues. All of these things play a key part in understanding the key aspects of business analysis. So when we understand these things, we can understand the market that we're working in, or that we're thriving in, or that we're being challenged, and then also understand our competitors, what the opportunities are as we try to make decisions that are going to improve the business. So if you think about some inspiring data-driven companies, Netflix knows everything about every movie that I want to watch or that I've seen. Google has a way of basically identifying every place that you've typically visited. It hosts information about you and your search. It also might have information about your travel. So there's a lot of information that Google contains or maintains about its particular users. Companies like data-driven companies like Coca-Cola and DBS Bank, there are very different organizations, but they all have the same need for data. So the key business grid is a way to look at how businesses and organizations prioritize their business questions. So pipe dreams, the idea that it's a potential learning opportunity that's difficult to translate into concrete market actions. That's a pipe dream. You hope for the best, you wish for the best, but it doesn't always land you with the best outcome. Then, of course, you have like the high value KBQs, key business questions, opportunities for deriving significant business value from analytics. You have the curiosities and the incremental movements or incremental improvements. So each one of these has some means of low ability to activate, a high potential to impact, high ability to activate, and low potential to impact. So we should ask ourselves 5 key questions about product penetration. How much did we sell? Product utilization, to what extent are customers using it? Consumer exposure, how many consumers saw it? Consumer engagement, how engaged were the consumers? And then conversion activity, was the intended value realized? So for instance, when you put out a marketing campaign, do you get back the expected benefits of that marketing campaign? In our particular example, we'll look at a company, EcoGlow, that essentially had data which made decisions, projected out what the return on investment would be, and obviously they either delivered or they didn't deliver. So you will have the opportunity to investigate as you read through that case. Then when we think about data, sometimes we think about what we see on our desktop, but really Data lives in an ecosystem. It lives in the cloud, it lives in your computer, it lives in your watch, lives in your refrigerator. Data is all over the place, and that data is being transmitted using various technologies from wireless to wired, using high-speed internet, using networking within organizations. And then there are a myriad of different systems that might be consuming that information. So these consumers of information might be in applications like an HR management system. It could be a system where it needs to do some processing of the data before it actually lands into some data warehouse or some database. So information is available and it's coming from many different places. It includes the generation of that data. Like when you're using your watch to track your walk, that is data that's being collected. That data is being transmitted to your application that might be on your watch, which might end up in the cloud. There's a collection of data. You might have systems on your car, monitors in your car that basically pick up your speed and transmit information back to an insurance company, for instance. Processing data. So once that data arrives in some type of system, that data needs to be processed, which means sometimes it needs to be cleaned up, sometimes it needs enrichment, which means giving additional information or adding additional information to that data in order to make it more valuable. Storage, of course, we store data in the cloud, we store data on pocket devices, we store data on personal storage devices. If you have like 1 gigabyte or 2 gigabyte capacity hard drive that you use for backup. And then of course management of data. Information is key and it has to be managed, it has to be maintained and controlled so that its value will be derived. And then of course once this data is available, as business analysts or as business users, we sometimes have to do analysis in order to understand the benefit that we're going to gain from this data, and that is the implied knowledge of either understanding how we're going to advance or the implied knowledge of understanding what issues or problems might come up as a result of some action or transaction or just some knowledge that we gain from that data itself. And then, of course, visualization. The key thing about data is it has to be visualized so that people can actually interpret and understand it and be able to use it to make decisions. That interpretation is key. A good data visualization, a good analysis makes interpretation sometimes great, but sometimes data can be challenging in that the decision you make is not an easy decision. It could be a build or buy decision when you might have the opportunity to either build something in-house or outsource it. So all of these decisions have some type of repercussion. And then of course we have to think about the types of analytics. So there's the idea that you're looking back, so that's the hindsight. And then of course you have oversight, foresight, insight, and right sight. So we'll spend most of our time actually in the descriptive analytics in the hindsight, looking at historical data. More advanced classes would look ahead as far as the diagnostics, predictive, prescriptive, and cognitive. So you should be familiar with these terms as you think more about the data analytics space. So again, descriptive analytics is really looking back. It's at what happened or what is happening currently. It's in your daily operations, it's in your sales, it's in what's going on with a patient. All the information is looking back and understanding what is occurring or what has occurred in the past. So the importance of data types and categories. When we think about data, sometimes we think of it as being in the form of information that might be in a book is data. It might be in a database. It might be in an Excel spreadsheet. It might be numbers. It might be text. But all of this information can be categorized in two ways. Either qualitative, which is really about aspects of data that are not necessarily used for mathematical calculations. And then you have the quantitative, which is used more or less for calculations. So think about it in that way. You have the qualitative and then the quantitative. So categorical data, as you can see here, really puts things in classifications, right? So car, truck, van, driver, there are a number of people. So the method or mode of transportation would be your category, but the number of people is actually qualitative or quantitative. You can actually do a calculation with that. So think about things being values that can be used in mathematical equations, and then values that are not necessarily meant for mathematical equations, but they give you a quality of understanding about a particular topic, issue, or concern. So then you have your ordinal variables. So ordinal variable is those values defined by order relationship between different categories. So for instance, when you're thinking about classifying things as a rating, so you have your excellent, very good, good, bad, and very bad. Those numbers are representative as we understand them to be. As you go higher or the number increases, then typically what happens is the value increases. So 1 might be very bad, a 5 might be excellent. However, those ratings can be applied to the number of students who might fall into a particular category. You might have 5 excellent students. So 5 excellent students would be 5 students rating with a 5, whereas 1 student here would be rated with a 1, meaning very bad, as an example. Numeric variables. A numeric variable, of course, is the quantitative variable that I was talking about. It's something that you can actually use in calculations. And then, of course, date and time and Boolean. These are self-explanatory in some ways, in some sense. So date and time is exactly that, a date and a time. And then Boolean variables might be a 0 or 1, or yes or no, or true or false. So essentially, they have some value as far as being numerical, but they're not meant to be quantitative. They're meant to use to classify things. Then data collection. So data collection is really about where information is stored. How do you get information? And so we'd have to think about these questions that we need to ask, like what is the current situation and where is it happening? As an example, why is this situation occurring? What is the data going to be used for, and why is it being collected? How will it be useful, and whom will it be useful to? So when we think about collecting data, we have to realize that you just can't collect all data. You have to have some means to identify what, why, how data is going to be collected, because that's going to be the most important aspect of really understanding the reason that data needs to be collected and what its purpose is going to be. And data collection is essentially determining where you're going to collect data from in order, and how you're going to collect that data into a system. So we think about primary data collection being 2 types again, the qualitative data and the quantitative data. Then of course, secondary data collection is data that we don't necessarily get directly, but it might come to us in some other form or fashion, such as when you receive data from reports on research, or that's data that's likely to be in a database that you can access. So you didn't necessarily create the data, but the data was made available to you. And then the examples of data collection methods include online forms and questionnaires, internet tracking, web-based marketing analytics, social media monitoring, and transactional data. So when we think about data, let's think about it in a framework, as in being, we understand the business problem. 2, we understand that this data needs to be cleaned or enhanced in some way in order to make it more valuable. Then we create visualizations. These are dashboards, charts, reports that people can easily understand and interpret the information in front of them. And then we generate hypotheses. So based on the data that you have in front of you, you're going to make a decision or hypothesize about how that data is going to be useful in making that decision. Whether or not you should invest in a particular organization as far as stocks, bonds, etc., or maybe open up a new store in a particular neighborhood based on market dynamics. Conducting analysis means running tests to determine if your hypotheses are correct. So you can have an idea in your mind that you believe is valid. However, you need to run statistical analysis in order to determine if that thought has validity and is assumed to be correct, or at least has a low propensity to have high risk that will not be beneficial to what you're trying to achieve in the long run. And then once you have done your analysis, you have to communicate the results, present your findings to those individual stakeholders or customers who might need it or are looking for it in order to understand what their next steps are. So the things that we need for analytics include critical thinking, hypothesis formation, which is really contemplated on the problem and understanding the possible outcomes, and having a feel for something, meaning that you believe that X will result in Y, and using data in order to prove out that hypothesis. So data wrangling is really about taking data, cleaning data, making sure it's in a useful format so that when you actually put it into your data analysis, then it will actually prove to be useful information versus misinformation. And then mathematical ability. Of course, when you think about the more technical aspects of business data analytics, is really written around a bunch of models, which are nothing but algorithms. And so very important to have very good math skills. And then, of course, data visualization. Data visualization is turning data into something that can be easily interpreted, digested, consumed. It really gets down to reports, dashboards, charts, graphs, and things of that nature. And that's what business data analytics, from a standpoint of introduction, that's where we're going to leave it off at.